Okay na. Okay, let's have this example. 2, 3, and 4 ohms. Transform this into an equivalent Y. Number 2. And number 3. This is terminal 1, terminal 2, terminal 3. 1, 2, 3, 1, 2, and 3. And 3. Yan. This is 5, 6, 7. This is 9, 10, and 11. We will be transposing this into an equivalent Y.
Okay, in the first problem, the transform circuit is this. Okay, this is your A. We have the your B and C. For delta to Y transformation, you try to recall the rule. For delta to Y, the Y connected legs is equal to the product of the two adjacent legs divided by the sum. So this is A is equivalent to product of the two adjacent legs, that is 2 times 4, divided by the sum of the delta connected resistances. So it is 2 plus 3 plus 4. Okay? For the value of B, product of the two adjacent legs of B, that is your 2 and 3, divided by the sum, that is 2 plus 3 plus 4. And the third one, product of the two adjacent legs, that is 3 times 4 divided by the sum. Then if we will try to compute, the denominator is 9, so that is 8 over 9, 0.889 ohms. Second, .667, and the third, that is 1.333 ohms. Okay, these are the ohmic values of the equivalent Y, transformed Y. We will try to draw. This is your A, that is your B, we have there your C. Okay, we will try to draw the equivalent Y. It should look like this. That is 1, 2, and 3. Your A, that is 0.889. Your B is 0.667. Your C is 1.333. Okay? Next, for number 2, transform your delta connected resistances whose values are 5, 6, and 7 into an equivalent Y. You need to identify here correctly where are your terminals. These are your terminals. Okay, try to mark these terminals by a bigger shaded circles. That is where you will be connecting the legs of your Y connected or your Y connection. Yan, 1, 2, and 3. So this is your D, that is your E, and this is your F. Okay, let us try to find what is D, E, and F. So for D, from the rule, sum of the products of the two adjacent legs, that is 5 and 7, 5 times 7 divided by the sum of the delta connected legs, that is 5 plus 7 plus 6. For E, product of the two adjacent legs, that is 5 and 6, divided by the sum, that is 5 plus 7 plus 6. And F, sum of the products of the two adjacent legs, that is 5 and 6. 5 and 6. Adjacent legs of F, that is 7 and 6, divided by the sum, that is 5 plus 7 plus 6. Ayan. So the sum of this, that is 12 plus 6 is 18. 35 all over 18 is 1 point something. 1.944. Another one, 30 divided by 18. 1.667. Then the other one, 2.33 ohms. Okay? So if we will try to redraw the equivalent circuit, yun lang. This is terminal 1, terminal 2, and terminal 3. This is your D, 1.944, 1.667, and F is 2.333. Okay? In our last example, your 9, 10, and 11 ohms are in delta. You need to convert this into an equivalent Y. You try to mark your terminals. This is terminal 1. Ito. Terminal 2 and terminal 3. This terminal is also terminal 1. Parehas lang yan, no? If we will try to place now your resistors, yan. One resistor here, isa dyan, isa rin dito. Okay? Sabihin natin this is your H, I, and K. Yan. Using the rule, your H is product of the two adjacent legs. Okay, for H. What is the adjacent legs of H? It is 10 and 11. Divided by the sum, that is 9 plus 10 plus 11. Then for I, product of the two adjacent legs, that is 9 and 10. 9 times 10 divided by the sum, 9 plus 10 plus 11. And the last, that is your K, product of the two adjacent legs, which is 9 and 11. So 9 times 11 divided by 9 plus 10 plus 11. Okay? If you will try to compute that, this is 20. It's 10 times 11 divided by 20, 5.5. 90 divided by 20, 4.5, and the last divided by 20 is 4.95. Okay, so if this is redrawn, the equivalent circuit is redrawn, it will look like this: terminal 1, terminal 2, and terminal 3. 1, 2, 3. Alright? This is your K, 4.95. This is your I, 4.5. And this is your H, which is 5.5. Nasundan. Okay, that is for delta to Y. Okay, let's have your Y to delta.
Okay, this is our next step. Yan.
We will try to transform this into delta. So for the first problem, okay, yan. This is how the transformation should look like. This is your A, that is your B, and that is your C. So that when the Y connected resistances are replaced by an equivalent delta, it will look like a delta. Yan. This is terminal 1, terminal 2, and terminal 3. Yan. This is your A. We have the real B and C. What is the value of A? Value of A, if you try to recall the rule, from the rule, sum of the products taken 2 at a time. So this is 2 times 3 taken 2 at a time. Okay? Plus 3 times 4 plus 4 times 2 divided by the opposite leg or the third unused leg. We have used your legs 1 and 2. The other third leg is your denominator. Ayan. Letter B. The denominator is the same or the numerator is the same. That is 2 times 3 plus 3 times 4 plus 4 times 2 divided by the opposite leg. That is your 2 ohms. And for C, yan. For C, the same numerator, that is 2 times 3 plus 3 times 4 plus 4 times 2 divided by the opposite leg, which is 3 ohms. We have used your legs 2 and 4. So the third unused leg is 3 ohms. The same is true for leg B. We have used your legs 3 and 4. Ang hindi natin nagamit is 2 ohms. Okay? So this is equivalent to 6 plus 12 plus 8 plus 12 plus 8, that is 26. 26 over 4 is 6.5. Then 26 all over 2, that is 13. And 26 all over 3, that is 8.667. Okay? That is how we proceed into Y to delta. How about in the second problem? Problem number 2. 5, 6, and 7 are in Y. So let us transform this into delta. Okay? Supposing that that is your A, B, and C. What is A? Let us try to recall the rule in y to delta again. The rule for y to delta is sum of the products of the y connected legs taken 2 at a time. So taken 2 at a time, 5 times 6 plus 6 times 7 plus 7 times 5 divided by the opposite leg, that is 7 ohms. Okay, and for B, the numerator is the same, that is 5 times 6 plus 6 times 7, or for B, we have the same numerator, that is 5 times 6 plus 6 times 7 plus 7 times 5, all over the opposite leg of B. We have already used your legs 6 and 7. The opposite leg is 5 ohms. Next is the resistor C. Same numerator, that is 5 times 6 plus 6 times 7 plus 7 times 5 divided by the opposite leg. We have used your legs 5 and 7. The third one is not used, so this is our denominator. Computing, that is 30, 42, 35. So it is 107 divided by 7, that is 15.286. 107 divided by 5, 21.4, and the last is 107 divided by 6, 17.833. So if we will try to redraw the figure, we will now have the equivalent delta, that is your A, B. Okay, this is yan, terminal 1, terminal 2, and terminal 3. That is your A. So this is 15.286. This is your B. So this is 21.4, and we have there your C, that is 17.833. This is the equivalent delta of the given Y connected resistors. Okay, next, let's have number 3. Let us convert your 8, 9, and 10 that are in Y into equivalent delta. Okay, this is the converted resistance, supposing that this is your D, E, and F. Okay, D, E, and F. Okay, so for letter D, let us again remember the rule. Sum of the products taken 2 at a time, that is 8 times 9 plus 9 times 10 plus 10 times 8 divided by the opposite leg, which is 10 ohms. We have used your legs 8 and 9. The remaining leg is your denominator. So letter E. Okay, resistor E. Same numerator, 8 times 9 plus 9 times 10 plus 10 times 8 divided by the opposite leg, which is 8 ohms. And the last, that is your F. Same numerator, that is 8 times 9 plus 9 times 10 plus 10 times 8 divided by the opposite leg, that is 9 ohms. Okay? The numerator is 72 plus 90 plus 80. That is 242 divided by 10 is 24.2. That is 242. 242 divided by 8. 30.25. Next. That is 26.889. This is now the equivalent delta. So if you will try to redraw your figure, it will look like this. That is your D. We have there your E. And finally is your F, the equivalent delta. Let us say that this is terminal 1, 2, and 3. This is terminal 1, 2, and 3. Okay? So this is how you will be using your Y to delta transformation. Let us now put your formulas or principles in terms of a practice.